Hi guys, in this video we are going to work with Identities Grade 12. Right, for Grade 12, it's very important to remember your identities, especially from your pre-period knowledge, which is sine squared plus cos squared equated to 1, as well as tan theta is equals to sine theta divided by cos theta. The first one, it's a square identity. The second one, it's a quotient. It's a quotient. Then it's a quotient. Then we also have the double angle, as well as the double angle. You may remember that we have a double angle of sine 2 theta, which will give you 2 sine theta, as well as cos theta. Right? We also have a double angle of cos 2 theta, which will be cos squared theta minus sine squared theta, as well as we also have 2 cos squared theta from that are derived from this. Also have 1 minus 2 sine squared theta. So these are the identities that you must keep in mind, right? So in this video we are going to apply, especially for trigonometric proofs, right? Consider that you are required to prove that. Consider that you're required to prove that sine, maybe sine 2x minus sine x divided by cos 2x plus cos x equated to sine x divided by cos x plus 1. Okay, cos x plus 1. So first thing first, check the easiest side. In this case, we can see from the right hand side that there's only cos x plus 1 and sin x. So we don't have any identity, so we cannot work with the left hand side. In this case, we can work with left hand side. So let's put this into practice. First thing first, since we are having sine 2x is the same as 2 sine theta and cos theta. It's a double angle. So we are going to have sine 2x as well as cos x minus sine x. Okay, divided. We also have another double angle, which is another thing, guys. It's also important to know your compound angle, because some question may require compound angle, but in this case we're having a question that has a double angle. So we have cos 2x. Which identity will be suitable in this case? Since we have in the denominator of cos and sine, what about taking since our denominator has cos from the right hand side, what about taking this one? This is suitable. So we are going to say 2 cos squared x minus 1. 2 cos squared x minus 1. Remember that we have plus cos x, right? So let's rearrange this. We have 2 sin x cos x as well as minus sine x. Okay, then let's rearrange. We have, this is a trinomial, guys. It's a quadratic trinomial. So we have 2 cos squared x plus cos x minus 1. Right, you can see that it forms we can see that it forms a trinomial. So what we could do is we need to always look for a trinomial. We can see that there's a trinomial in this case, but there's a highest common factor here. Look for a highest common factor after this step. The highest common factor is what? It's going to be sine x, right? So sine x, then what are we left with? We're left with 2 cos x. right? To get to minus sine x, we need minus 1, because sine x multiplied by negative 1, that will be negative sine x, divided by, right, let's go, divided by, so from here, you can factorize, since it's a trinomial. What will be the factors? Factors of 2 cos squared is 2 cos x, right? Factors of 2 cos squared x, it's 2 cos x multiplied by cos. Factors of negative 1, that's going to be 1 and 1, because since the last term is negative, the signs will be different. Here we'll have minus 1, and here we'll have plus 1. So we can see that there's something, there are common brackets here. Common brackets will cancel each other. We are left with what? We are left with sine x divided by cos x plus 1. Right? So I guess we have proven the left hand side. We have proven that the left hand side is equals to the right hand side. So that's how you can apply identities in this case. So let's look at the second question. Now we are on a second question. We are given 1 minus cos 2 theta divided by sine 2 theta, which is equated to tan theta. We need to prove, right? First thing first, guys, here you need to choose an option that will eliminate this cos 2 theta, because we need to be left with sine here. Definitely, you may recall from our identities, we have that one that says 1 minus sine squared theta is equals to cos 2 theta. Okay, you still remember that identity? We did have that. So we are going to say left hand side. Left hand side is equals to 1 minus 1 minus 2 sine squared theta. Okay, right, divided by sine 2 theta. Okay, I was supposed to change this, but it's fine, I'll change it. So the second step, this is 1, and negative multiplies everything here. So we are going to have minus 1, and negative multiplied by negative 2 sine squared, that will be plus 2 sine squared theta. Okay, then we have sine 2 theta. Sine 2 theta, it's a double angle of sine. So what we can recall from a double angle of sine is that it will be 2 sine theta as well as cos theta. Okay, so what is happening? This 1 minus 1 are like terms, so we are left with 0. So we are left with 2 sine squared theta, right, divided by 2 sine theta. Divided by, okay, multiplied by cos theta. So we could see that we can cancel this, they are common. So we are left with 1 sine here at the numerator, because there are 2, so we cancel 1. So we are left with sine theta divided by cos theta. So what is that? That will be tan theta. In that case, we are left with tan theta, which is the left hand side. Remember that the left hand side will be equal to the right hand side in this case. So we have proven, guys. So it's a matter of understanding how to apply the identities. Hope you find this video useful, and don't forget to subscribe and like. We love you.